Hi, I'm Cormac. That's my dad. I'm pretty proud of everything he's done in his life. He's gone to Antarctica 40 times, and he's done a whole bunch of other things that he'll probably tell you a bit about. And I'm really excited to have him here to talk about Antarctica and then talk about why Antarctica is really important and crucial as the Earth starts to heat up. So I have a few organizations and people to thank. So first, the Wesleyan Green Fund, which is funding the majority of this event. The College of the Environment with Professor Barry Chernoff. Earth Environmental Sciences with Professor Daniel Roy, who's right there. WESU Middletown, 88.1 FM, the Wesleyan Sustainability Office, the Climate Action Group, and the Wesleyan Artists. So yeah, hopefully a few more people will kind of trickle in as the event gets started. But my dad is going to do like a short movie to start us off, and he'll start talking.
Well, good afternoon, good evening. Great to be here at Wesleyan. I made a career out of going to Antarctica, and it's not the most usual sort of profession. And I was going to start off by explaining a little bit how I got to work down there. For me, it was quite a long journey before I finally got to where I am today. I grew up in Adelaide in South Australia, and it's the driest state in the hottest, driest continent. We have a about 25 million people in Australia, a fraction, 1/13 of the US population. But you can see that the area of the two countries is quite similar, or continental USA anyway. And so there's a lot of open space in Australia. Most Australians are coastal people. We have all of our major cities on the shores of Australia, and so I grew up going to the beach for our holidays, our vacations every summer. And so my earliest dreams were to be a scuba diver. But it wasn't until I got to university in South Australia, Flinders University, where the sports union had enough money to be able to afford scuba equipment, and I learned how to dive and became a very keen, passionate scuba diver every weekend. And university holidays, I'd go diving with friends, and got to the point where I was one of the office holders, and we started getting work with a graduate student who was building oceanography equipment, current meters. And when he graduated, he went into a private company deploying these current meters all around the country. And because I've been working with him, he offered me a job straight out of university. So my first job in the business world was working as a scuba diver, which was like a dream come true. But if you're wearing a wetsuit 5 days of the week, the last thing you want to do on the weekend is actually put on a wetsuit. And so I looked around for something different to do, something equally interesting and exciting. And a school friend had been into rock climbing, and he took me rock climbing, and that's when I really discovered my true passion. And so I ended up spending about the next 10 years going around the world, trying different sorts of climbing. Of course, there's not many high mountains in Australia. You have to go to New Zealand before you get real alpine climbing. And then, of course, big wall climbing in the United States, and alpine climbing in Chamonix. And then I started going further afield into some of the mountain ranges like in South America and the Himalaya. But, I'd given up my career as a scuba diver, obviously, to fulfill my passion as a climber. But somewhere along the way, I realized that I needed to find another way to make a living. I had a job for a few years as a salesperson in a climbing store, and ran some trips for school kids going cross-country skiing in Australia, which is a lot of fun. I remember digging an ice cave in a snow area of Australia with some schoolboys, and had this sort of epiphany that I was actually being paid to do this, and how cool that was. And so I achieved another dream of starting to work in the outdoor field and earn some money. But being based in Adelaide, I knew there was a big wide world out there. I travelled to a lot of places, and I knew that it wasn't really sustainable for me to stay working as a sort of shop assistant in a climbing store. And I had ideas of exploring further and trying to make a lifestyle out of it. But I went to South America. But before I did that, like most people, I started out with a sort of camera as a kid. In my case, it was a box Brownie. But it wasn't until I got to South America, and I travelled with another Australian who was a photographer. He was living in England, and he called himself a photojournalist. And I'd never been exposed to anyone who had that sort of work. I didn't really know what the term meant, but he said he'd been able to make a living as a photographer, and consequently started to pique my interest about perhaps that was some way that I could support myself. And so for the next few years, I started to explore the idea of taking photographs and writing stories. And my next big break came when I got hired or invited to join a climbing expedition to the Himalaya, attempt to climb Annapurna 3, which is one of the very high mountains. And it was a big team of people. We had, I guess, about 20 climbers from Australia and New Zealand. And when we set off, it was with about 150 porters, and we were trekking a long way, about a 10-day trek to the back of the Annapurna range. And I can remember it was in March, and I was sort of so caught up with this business of documenting the expedition, and of course it was with film cameras in those days. And it wasn't until 5 o'clock in the afternoon one day that I realised it was actually my birthday. I don't know how ever many of you have been doing something and you haven't remembered it was your birthday. But that's how intense the experience was. And we got established on the mountain and started putting camps up. and then tragedy struck. An avalanche came down, buried our camp, and knocked over the tents, and I managed to dig myself out, dug out my companions, and we thought, oh, one other person had been lost, and then eventually, a few hours later, they came walking up the hill, and the tent they'd been in had been bowled down the hill. And so everyone survived. But the next day, when we were descending to base camp, another avalanche struck and carried away 4 people in front of my eyes. We managed to get down to where the avalanche had stopped and dug out one person, but the other 3 people died. And so the expedition had to be abandoned, and the challenge was that I'd been, documenting all of this, and we got a lot of sponsorship, and we had an obligation to go back to Australia and talk to, the country about what happened. And so I put together a slideshow, which for me was a big challenge to talk about these people who died and our story, and it was a memorial to these people, plus a thank you to the sponsors. And for the very first time, standing up like I am today in front of people and telling a story with photographs had a very powerful effect on me, and doing it time and time again around different cities, I realised that here was a new way that I could explore myself, challenge myself, was to become a sort of visual storyteller. In those days we had 2 slide projectors and a dissolve unit, so we had a much more primitive way of achieving what we can do today digitally with very easily. So I then decided that this was going to be something that would sustain me for many, many years. The challenge of storytelling and going to these wild and remote places and being an adventure travel photographer. But how do you get to Antarctica? That's the big question. And it doesn't matter what you do in your life, whether it's to do with your career or some sort of interest you have. My advice to you is to find a mentor who can help you along your road, whether it's a professor or a family friend or just someone who is doing the sort of stuff you like to do or is interested in the same things, who can guide you. And so my mentor was the leader of that Annapurna expedition, who was an ex-army major who'd done some amazing climbing in his day. In fact, he'd led a sailing expedition to make the first ascent of a mountain in the middle of the South Indian Ocean called on Heard Island. And he introduced me to 2 Sydney climbers who were organising an expedition to try and climb the same mountain. And so I became part of a team going to the Heard Island to try and climb the mountain. And we were sailing from Perth all the way to Heard Island, doing that climb, and then sailing all the way back to Australia. Now, Heard Island is incredibly remote, one of the most remote places in the world. It was discovered by sealers in the early 1800s and named after an American sealer of all things, and was claimed by the United States for many years, and they wiped out all the elephant seals there in about 30 years, and then it became a British territory, and then finally it became an Australian territory in 1947, but it has a mountain that is 9,005 feet, 9,006 feet tall. It's an active volcano, and so technically is Australia's highest mountain, even though it's not part of the Australian continent, so to speak. And it's 1,000 miles from Antarctica, so it's right out there. But the interesting thing is, from a geographic point of view, that it's within what we call the Antarctic convergence. We'll learn a bit more about that later. It's the biological boundary of Antarctica. So we sailed there, and this is the mountain on one of the very few good days where you can see the summit. Typically, it's always shrouded in cloud because it sticks out there in the middle of the Indian Ocean and it makes its own weather. And so you can have 60-knot winds from one direction, and then a few hours later, 50 knots from another direction, snow, sun, all in the same day. So the original team that went there gave us some good information, and our mode of transport was a 93-foot maxi racing yacht built of ferro cement. And I'd never been in a sailing boat before, so this was really a sort of scary experience for me. When we set off from Perth, this yacht was pounding through these waves because we were sailing directly into the westerlies. So we had to go sort of due west from Perth before we went south, because if we would have been, if we diagonal down to Heard Island, we would have been making the hardest route possible. but it was the coldest, most miserable I've ever been. I mean, I've been cold on mountains before, but that was a sort of dry cold compared to the wet cold of being drenched on a sailing boat. And it took us about 2 weeks to get there by sail, but eventually we made it to the mountain and established our camp right at this end here. And you can see the schema, you know, it dropped 9,000 feet straight out of the ocean, and it was one of these things where we were route finding, making a new route, and these windstorms would come, and you know, we had a camp of tents on a ledge, and the wind would be so strong it would just smash our tents up. And so we eventually learned that we had to live in ice caves to be able to make it through the night, and that's what we eventually did in a cave up here. And then we made our way further up. It's an active volcano, so all the rock there is very recent, it's very friable. You know, there's a saying, if you want a good hold, you pick one up at the bottom and put it in your pocket, because it also loose and it's like climbing on what we call wood picks. So it was very challenging. We had to find our way up the ridge and then through a maze of crevasses. And finally we got to the summit, and this was a cloud of sulphurous gas coming out. You can see there's no snow there, and the steam drenched all of our outdoor clothing, and it was sort of like being in a Turkish bath. And then we got down off the top of the mountain back to below where the fumaroles were pushing out this hot gas, and all of our clothing sort of froze because it was completely damp, and so it was like wearing a suit of armour. So it was a very, very interesting climb, the second ascent of Australia's highest mountain, and we made it back to the coast, and then sailed all the way back to Australia. And you know, we had a hell of a time getting there against the westerlies, but on the way back we were on one tack, which means that we didn't have to change our sails more or less for the whole way back. And surfing down these big waves in a 90-foot yacht, the biggest danger you have in that sort of conditions is that the yacht goes up end for end, calling pitch poling. And if the waves are too steep, then that can be a pretty untimely end. So we were pretty scared, even though we were not having sort of waves breaking over us. It was surfing down waves that was the challenge. So we get back to Australia, and as many of you know, Australia is a very flat place, and Uluru, the giant rock in the middle of the country, is quite well known. Less well known is the fact that Australia's highest mountain is Mount Kosciuszko. And all these X's are where there is rock climbing, good rock climbing in Australia, but there's not much mountaineering. Uluru is now managed by Aboriginal people, traditional owners, and they prefer that you don't climb it. I was lucky enough to climb it long before it was given back to them, and now they discourage you strongly from making an ascent because it has a certain sacred quality to it, which is understandable. But Kosciuszko is no real challenge for climbers. In fact, I think you can drive a car to the top of it, but it is a lot of skiable snow there, and it's a great place to enjoy the outdoors, but not for climbing. So, you know, Australians who are interested in adventure look south to Antarctica. As you can see, it's quite a long way, but still, if you live in southern Australia, that's the focus. And growing up in Adelaide was special for me because it was also the home of Australia's most famous Antarctic explorer, Sir Douglas Mawson. He was a geologist, started out in Sydney, went to Antarctica with Ernest Shackleton and came back and was invited to go to the South Pole with Scott. But he turned Scott down in favour of organising his own expedition, and he got together a team from Australia and New Zealand and raised the money and sailed down there. And at that stage, Antarctica was very little known. This is more or less what he was heading into. And then from 1911 to 14, he was there with a team of men. They took sled dogs there, which was the main mode of transport at that time. And they had with them one of the most amazing early photographers, a gentleman by the name of Frank Hurley, who's one of my personal heroes. And so this is not long after the advent of photography, of course, and cinematography. And so he's there got a hand-cranked Moody camera, and very few people had been exposed to Antarctic wildlife, seals and penguins and so forth. So he went to great pains to document the wildlife, but also he did some amazing work documenting the expedition. And this is some of the footage from one of his early films, and of course they were silent films in those days. But you can see there, they happened to build the huts, erect the huts in this valley, which turned out to be one of the windiest places in Antarctica. And we have what we call katabatic winds, which is where this cold, dense air flows down off the ice cap. And it blows relentlessly day in, day out. And in fact, he wrote a book about the expedition, and the book is called The Home of the Blizzard. And you can see there, this was sort of probably in the fall, and there's no water there. So if you are wanting to get fresh water, the men had to go out every day with pickaxes and chop ice, put it into a crate, as you saw, and then carry it into the hut and melt it in these big pots on a coal-fired stove, which also provided the heating. And so one of the classic images that Frank Hurley took on this expedition was called wetter and close, collecting ice for domestic purposes. A very sort of deadpan description of what must have been a daily chore that was by many sailors hellacious. And so Hurley was a great storyteller too. He worked out that he needed to sort of have footage of all of the day-to-day things that were so unusual by comparison to how we normally live our lives. And this is how you erect what we call a polar pyramid tent in a windstorm. And he actually had to create a sort of enclosure with stones and snow to be able to shelter in, to actually make this footage of these poor people trying to erect a tent and not have it blow away. And so they have a sort of flap around the edge of it that they load up with all the snow they've gathered, and then they'll sort of crawl inside and make themselves comfortable. So it's an amazing place to visit, Commonwealth Bay. And the idea of our expedition was to go there and work on the conservation of Sir Douglas Mawson's huts. The huts were still there after all this time, and but there was a danger that they would blow away because the winds were so strong. And with a sort of appreciation for the heritage of these early explorers, we really wanted to try and raise people's consciousness about what the work they'd done. And so we organised a small expedition of a dozen or so people. We sailed there on a tiny yacht, and we did some of the, not quite reenactments, but we explored in a similar way, hauling sleds and putting up polar pyramid tents in these very intense windy conditions. And occasionally we experienced what we call a brown blizzard, where it's snow and you can hardly see your hand in front of your face. But it is a place where, even on a clear, nice day, you've got this wind blowing so strongly that you can actually lean almost horizontal to, and be supported just by the force of the wind. And you can see there's no exposed flesh on me at all, because it's so cold with at 0 degrees, and then you have wind chill. It's probably minus 20, minus 30 with wind chill. So the main goal of the expedition was to work on the huts. We managed to tunnel our way inside, and you can see there they had snow covering most of the huts during the winter months, and the real challenge was to sort of inspect them, and this is where we tunneled right inside to where Mawson had his own little cubicle. You can see the names of some of the early explorers on the hut, on the bunks. And this is the condition of the hut when we were there back in 1980. And the outside of it, the timbers are worn very thin because of the blasting of ice and snow from these katabatic winds. And so it was a project where we really worked together as a team. It was an incredible environment to be in, and we had a sort of ulterior motive that wasn't a climbing goal, but working with archaeologists and conservators from Australia. We conducted a lot of different tests and documented some information and took back to get advice how to proceed. And it was, a comprehensive project. Before we went, I managed to get a contract to write a book about the expedition. And I was, very inexperienced in that sort of work. I'd written magazine articles, but the idea of writing a book was a huge challenge. I like to think of it as a sort of Everest-like challenge for me. I wasn't a great English student, but I took my computer with me, and it was being powered by a generator which was out near the toilet. And someone went to the toilet and accidentally kicked the power cord out, and then when they plugged it back in, it sent a spiking power down and just suddenly smoke was coming out of my computer and it blew it up. So I ended up having to go back to traditional pen and pencil, pen and paper, but I managed to get my book finished. This is the ship we went on, a very tiny 21-metre steel hull, about 60 foot long, converted fishing trawler, all the way to Antarctica, and that was an incredible experience. Very different from the one on the Maxi racing yacht, but the second time we went south, we chartered a converted lighthouse tender, which was owned by an English expedition led by an explorer called Robert Swan. And he was off trying to make it to the South Pole. And this ship dropped us off and then was going around, further around Antarctica to the Ross Sea, where it was going to rendezvous with Swan coming back from the South Pole. The only problem was that the ship came in close to the island, Ross Island, and got caught in pack ice and ended up being crushed and sank. They managed to get everyone off on the ice floes, and they were rescued by the National Science Foundation, people from McMurdo Sound that's nearby. But it was very sobering to realise that we'd been on a ship that a couple of weeks later sank. And so reminder of the trials and tribulations of being in Antarctica in tiny ships, the same sorts of conditions that many explorers had to endure. So I worked very hard on learning about the history of this whole experience in Antarctica and ended up writing my book after 2 years, and it was a huge achievement. It was very well received. It was a complete survey of Australia's Antarctic history, plus a story about 2 expeditions and the work on conserving these huts. So that was a great springboard to do other sorts of adventures that set me up in the world of mountaineering and adventure photography, from working on IMAX films to making a documentary about sled dogs in Antarctica, working as a guide at an Australian scientific base for a summer, and then also working on things like a virtual expedition to Antarctica with digital photography, and I ended up leading an expedition that shot the backgrounds for the movie Happy Feet. So I got to do lots of fun things in Antarctica, and along the way I authored a couple of books. But really all of that sort of led up to the point where I decided that, or it sort of fell my way that people asked me, well, I tried to sell them photographs, and they said, well, what else can you do? And I said, well, you know, I've been to Antarctica a few times, I've got a bit of experience. And they said, would you like to try being a guide? And that sounded pretty good. By this stage, I'd actually moved to the United States and was living in California. And so it was a small company based in El Cerrito called Mountain Travel that hired me as a guide. And within a short while, I became their senior expedition leader. And so over the years, you know, you need to get all sorts of experience to do that sort of job. And all the different things that I had done over the time had led up to me being pretty well qualified for that sort of job. And in fact, you know, it's not a high-paying job, but you know, people going there on these adventure cruises are paying $10,000, $20,000 to be there, and I'm being paid to be there. So once again, you know, going way back to being paid to dig an ice cave and then being paid to actually go to Antarctica felt like a dream come true. So over the last southern summer, Christmas time, I was joined by my family going on one of these ships. These are Russian research vessels. They're about 100 passenger vessels, very rugged, tough vessels. And the 2 of them that I mostly work on called the Sergei Vavilov and the Yoffi. And they are doing scientific cruises when they're not being used by our company for Antarctic tourist or Antarctic adventure cruises. And even when we are down there on these cruises, we are still collecting data with various sensors on the ship. And so obviously going to Antarctica, you sign up for a cruise that's either 2 weeks or usually they're 10, 12 days, but this was a longer one because it was going via South Georgia and the Falklands. And so it was a great thing to be able to go with my family for the first time. My son and daughter had never been, my wife had been once 30 years ago. And of course we have to get all the way to the tip of South America, which is, you know, pretty much a day's flying. and you get down to a little town called Ushuaia, which is at the very bottom of the world, the southernmost city, in fact. And there, this is a gateway to Antarctica, and you have big ships like the one in the background who go around the world. They don't go to Antarctica, but these smaller ones here are all Antarctic cruise vessels with 100 to 200 passengers. They don't allow the bigger ships to go to Antarctica because they use heavy fuel, which would be very bad for the environment if they were to have an oil spill or an accident. And imagine dealing with 2,000 passengers if the ship had problems down there. Not a logistic nightmare. So on our ships we have 10 to 20 or 20 to 30 expedition staff to look after about 60, 70, 80 passengers. And we head off from Ushuaia. When we're working on these ships, usually we come in the morning, one group of passengers get off, and we leave that afternoon with another group sailing down the Beagle Channel, which is very beautiful. Most of the time it can be very windy, however. And then we've got to make our way across some of the roughest ocean potentially, but we'll either call it the Drake Sheik or the Drake Lake. And luckily on this crossing, which is about 600 miles, we mostly have Drake Lake, but on time-lapse makes it look like Drake Sheik. So you can be lucky. I've had some very rough crossings, but we were blessed with the good weather. And on our way across, one of the great pieces of or experiences of the environment are the seabirds, the albatrosses that can circle the globe. And we cross what we call the polar front or the Antarctic convergence. And eventually, when you get to see your first iceberg, you really know that you've started to make it to Antarctica proper. And maybe on the evening of the second or morning of the third day, you'll get to make a landing like this in a beautiful bay. And we use these Zodiacs, inflatable small craft to take a dozen or so people, and you can cruise around and enjoy seeing. These are humpback whales. They are very aware of your presence, and quite often you can turn the motor off and they'll just come up very close to you. And these animals are amazing. They'll come all the way from the tropics down to Antarctica to feed in the summer, and they gorge themselves on krill, and then they won't feed for the rest of the year. So we're in Antarctica in the beginning of summer, and it's light around the clock. One of the things you really want to do when you're there is land on the continent rather than on one of these offshore islands. So making a continental landing is a big goal. And then we have sometimes a day like this in Willamette Bay, which is quite often where we see lots of whales, but on this occasion there were lots of seals, leopard seals, which are the penguin killers, and other seals like the crab eater. And of course this ice, glacier ice, could be 10,000 years old, so we're always grabbing a piece of that to take back to the bar for our whiskey after the trip. You can get these amazing evenings where it's mill pond calm, and we have a different itinerary every time. Some of them go to the most visited place called Lemaire Channel, which is actually a nickname Kodak Crack. It's so photogenic, and our Russian crew are very experienced, and we have to somehow find our way through around this iceberg, a very narrow passage to get to some of the places below that, which are called where it's icebergs get stuck, and it's nicknamed Iceberg Alley. And so cruising around these towering icebergs, and remember only 1/8 of an iceberg is appearing above the surface of the water, and so there's a vast amount of ice underneath. And some of our passengers go camping and some go kayaking. And so you wake up in the morning and suddenly you realise you're in a penguin highway. These are what we call gentoo penguins. And penguins aren't afraid of you. They have no predators on land, so they just think of humans as big penguins. And if you sit down or get down to their height, they'll actually walk right up to you, especially the chicks. And then, of course, if you're wearing penguin, camouflage, they'll come even closer. But it's being in a zodiac when a whale comes up, that's the most exciting.
They came to us. Your Honor, I was just standing there.
bubble feeding. They had to swim around and sit down bubbles to trap the krill. It's a heart-stopping moment when that happens. I've never had an experience where a whale has actually touched the boat. They come very close. So all of what you've seen us doing has been right on the tip of the Antarctic Peninsula. We've just scratched the sort of surface of what we call the banana belt of Antarctica. And when I'm on these ships working, I'm giving lots of presentations like I am now to people on board, sharing with them our experiences and understanding of the geography, the history, the wildlife. And so I'm just going to spend a little bit of time talking about the basics of Antarctica and how incredible it is. So a few definitions to start with. You know, we talk about the Antarctic, and that's the whole region inside this Antarctic convergence, the wavy line. When we say Antarctica, we just basically mean the continent. And Antarctica is of crucial importance for the whole of the Earth's systems, particularly the physical and biological properties and the continent surrounding the ocean and the surrounding ocean that really links into everything else that's going on in the Earth through the oceans and the atmospheric circulation. The name Antarctic comes from Greek, opposite the Arctic or anti-Arctic, and Arctic comes from Arctos, meaning bearish, the constellation of the Great Bear that sits above the North Pole. So very interesting derivation of the name. And so just a quick little introduction to some of the aspects of the history of it. You know, the discovery of Antarctica is very recent in human terms. All of it really happened in the last 200 years. So you have to understand that it was Pythagoras who thought the Earth was round in 530 BC, and then Aristotle said if there's a big frozen mass in the north, then there must be a big frozen land mass in the south because of his concept of symmetry. And then we have Ptolemy in 130 AD drawing a map and conceiving of the idea that the Indian Ocean was enclosed, and he labels that area south of here Terra Incognita. And it wasn't until 1772 that Captain James Cook, sailing all the way around Antarctica, makes a crossing of the Antarctic Circle 5 times. He never actually finds the continent, he just finds ice, ice and more ice. He does discover South Georgia, but essentially he says that it's of no great use to mankind. But his accomplishments were quite amazing. And then it wasn't until the 1820s that the first person to actually sight the continent, Bellinghausen here in 2 ships, the Vostok and the Mooney. And then we get to the 1900s, and of course that famous challenge that explorers had set themselves to reach the South Pole. And you have Amundsen in 1911 beating Scott, and Jackman had tried earlier. So Antarctica really becomes a place that countries start to lay claim to, just as there'd been colonialism in other parts of the world. So the Antarctic had people making their claims as well. But the big challenge of these claims was that some of them are overlapping. Chile, Argentina and Great Britain all claim some of the same territory. So there's no way that that could go forward without some sort of resolution. And eventually that resolution came in an event called the International Geophysical Year in the 1950s, where countries from all around the world got together and did this big scientific push in Antarctica. And it was so successful that they said to the politicians, we need to do something about being able to work in Antarctica collaboratively going forward. And so they pressured the politicians to create what was called the Antarctic Treaty, which manages the whole area of Antarctica. It was first signed by 12 nations in 1959, came into force in 61. And it's the legal framework that the whole world operates on in terms of managing that area south of 60 degrees. So it's an incredible document, incredible organisation that looks after everything that happens in Antarctica. And so, understanding Antarctica, it has no human history up until 200 years, no native inhabitants, no permanent sort of presence there. And so the emblem of Antarctica has become the shape of it, both from the official logo of the Antarctic Treaty, and there's even a flag, an Antarctic flag. And so the outline of Antarctica, the geography of Antarctica, is that enduring emblem that we think of. And when you describe Antarctica, I think of it as a sort of misshapen tadpole with a short tail. So the way we view parts of the world and the way we view Antarctica can be distorted or confounded by how a globe is presented on a flat surface. And so you have a projection like this, which makes sense in some ways, but a projection like that shows the actual area of Antarctica properly and its relationship to the other countries around it. Then you get to a projection like that, which really messes Antarctica up. But a projection like this really distorts the size of Antarctica. But this is the projection that all of your Google Maps, your Apple Maps, most mapping for navigation and for finding your way works on. But obviously when you present it on a flat surface like this, Antarctica, it looks very weird. But this is the challenge is that when you're standing at the South Pole, everywhere is north. And in fact, a magnetic compass close to the South Pole, it's always sort of pointing, it hunts, it actually sort of swings around, it doesn't point anywhere. We'll get to that a bit more later. So why is Antarctica so special? Well, it's through the Antarctic Treaty, an amazing example of international cooperation. It's actually a protected wilderness because of the Antarctic Treaty, and the objects of the cooperation between all these countries is totally dedicated towards science. There is a sort of undercurrent of political one-upmanship and attempts to maintain power and position against the possibility of minerals being extracted from Antarctica at some time in the future. But at the moment, science is the currency of power and the way Antarctica is focused. And also, as we talked about, it's the engine of the world's weather. A lot of things that happen in the southern hemisphere particularly, and also further north, are affected by and impacted by what happens in Antarctica. It holds an amazing record of the world's weather. The ice layers trap air, and in that air are carbon isotopes that can be analysed, and they can work out the level of carbon dioxide when that snow was laid down. And so we'll talk more about that in a minute. And also, it's a very sensitive indicator of what's happening elsewhere. Antarctica is called the sort of canary in the coal mine in regards to global warming. Some other interesting facts about Antarctica: it's the highest continent, the driest continent. Most of Antarctica is what we call a polar desert. There's very little snow that falls there. When you see snow in the air, it's quite often being blown horizontally rather than falling out of the sky. It's the coldest continent, the windiest continent, and it contains 70% of the world's fresh water, 85% of the world's ice, and 98% of it's covered by glaciers. And it's a vast place. Look at the size of it. 3,500 miles from one side to the other, and almost 1.5 times the size of the USA. So it really is very large by comparison. It's mostly located within the Antarctic Circle. You can see there just a very small part of it pokes up above the Antarctic Circle, and it's also politically a place where you have these sort of sectors that are chopped up, but no one really takes much notice of those political divisions anymore. It's the 60-degree boundary that is of most importance. And as we mentioned before, the biological boundary of Antarctica is the polar front or Antarctic convergence, where cold water from the south meets warmer water from the north. And quite often you get a lot of bird life and fog when you're crossing that. And it's not a fixed line, it's a sort of zone that can be 5-10 miles wide, but it's very distinctive. When you cross it, the air temperature drops maybe 5 degrees, the water temperature and the salinity also drop. So the Southern Ocean is important because it's continuous all the way around Antarctica, and as I mentioned, the Southern Ocean, the northern boundary of it is the polar front or the convergence, and you have this Antarctic circumpolar current. It's very significant because it's driven by the westerlies, and it insulates the continent from the weather further north. It keeps Antarctica cold. In fact, Antarctica didn't really become covered in ice until in geologic time the continents drifted away from it and left it isolated such that these currents and winds could build up circling the continent unimpeded. And it's one of the largest ocean currents on Earth, and but my son was very interested in the term that describes ocean currents and how fast they are, Sturdraps. He was a Scandinavian oceanographer who got to name them. And as I said, it wasn't really created until Antarctica separated from Gondwana time, 30 million years ago. And so when I talk about it being impacting the rest of the world from a climate point of view, it's really these currents that actually circle right up into the Arctic and back down into Antarctica that take cold water, rich water with nutrients into the tropics and then back down and around. So this ocean conveyor, or the thermohaline circulatory system that starts in Antarctica and then goes all the way around the world, controls a lot of what happens in other parts of the world. Now, the interesting thing about the sea around Antarctica is that in winter it doubles the size, the effective size of Antarctica. And it's like a continent breathing in the cycles between summer and winter. And so you see here going out way much larger in area, and that means that it has tremendous importance in terms of reflectivity. Ice-covered water reflects 90% of the incoming radiation, whereas the dark sea absorbs so much more, and so the temperature is affected by how much of the sea is covered by ice. And also underneath that ice you get build-up of nutrients, and that's what controls a lot of the biology of Antarctica because of the fact that the krill feed on that nutrient-rich water. And as the sunlight starts to melt the ice at the end of the season and it starts to break up, you go from having fast ice, which is basically frozen sea, to pack ice. And pack ice is still very hard to navigate through unless you've got an icebreaker, but as it becomes more and more open, then the biological productivity ramps up and you get these incredible algal blooms, and then the krill start to build up, and that's what drives the biology of Antarctica. So we've been looking at the oceans around Antarctica. Let's look at the continent itself and a few other interesting facts. I mentioned how high it is, more than 6,500 feet on average, and you can see most of the height is on the right-hand side. And then you have things like the East Antarctic ice sheet. This is the highest area of Antarctica and controls a lot of the fresh water. It's basically a polar desert, featureless desert. It doesn't snow very much there, maybe an inch a year. And then you have the West Antarctic ice sheet, which is well below sea level. A lot of the ice goes right down to below sea level, and that's of great importance later on when we talk about the loss of ice. So the South Pole is important because it is quite high. It's 9,300 feet high, and the average annual temperature there is minus 48 degrees centigrade, minus 56, so a very cold place to be. But the Americans have a base there, the Amundsen Scott South Pole Station, and people live there year-round, and it's a very important place for scientific research because the atmosphere is very thin, very clear, and a lot of cosmic ray research and astronomy research is done there. And then you also have the auroral oval. Now, you know, we've talked about the geographic pole, but then you have the magnetic pole, which is off from the South Pole by a great distance. In fact, at the moment, it's in the ocean off Antarctica towards Australia. And the aurora are 30 degrees off the magnetic pole. So if you look at the auroral oval, it's that dotted line which is focused on the magnetic pole. And if you see the aurora from the sky, from a satellite, it looks like this. That's where cosmic rays are coming in and impacting on the Earth's atmosphere under the influence of the Earth's magnetic field. So it's a very spectacular thing. I've rarely seen it in Antarctica because I'm always there in summer when it's not very dark. And you have to be there in winter to see the aurora. And of course we have the northern lights in the northern hemisphere, the aurora australis is in the southern hemisphere, the southern lights. So Antarctica is also of interest at a place called Vostok, which is even higher than the South Pole. It is an example of where you combine latitude with altitude to get the coldest place in the world. Minus 89 degrees centigrade, recorded back in 1983. Now, Vostok is the Russian base in the inland. When the Americans put their base at the South Pole in the International Geophysical Year, this was at the height of the Cold War, just on the shoulder of the Cold War, and so the Russians, wanting to show that they were as good or better than the Americans, decided to go to an even tougher place to be, a colder place to be, which they called Vostok. And of course that's named after Bellingshausen's ship from the very first sighting of Antarctica way back 100 or so years before. But Vostok is interesting because when they started getting satellite information from the surface of Antarctica, they noticed this flat spot. And they worked out that that was actually ice, thousands of feet thick, floating on a very large lake. This is the size of one of the largest Great Lake in the US. And they thought, well, this would be a really good place to make an ice core. And so here they are. This is Vostok Station with the dual cores. A really, really cold, miserable place to be. Very hard to do work there. But the Russians, being the tough race that they are, sought the challenge. And they now extract ice cores that give us a complete history of the Earth's climate going back mostly upwards of 500,000 years if they get down to the bottom of the bedrock. And you can see there this lake that is huge underneath 2.5 miles of ice, and yet even so the surface reflects the flatness of the underside of the continent. So modern technology through things like satellite imagery has really changed our understanding of the Antarctic, and now through all of this sort of work with radar being scanned across the continent from planes, satellites, and then on the surface work with explosives using geophysical techniques which were developed by the oil industry applied to Antarctica in a scientific way, give us this map of Antarctica. And it's not surprising that the highest place in Antarctica Domain, in fact, sits on top of a mountain range that was only discovered in the 1950s. It's the size of the European Alps, called the Gamburtsev Mountains, named after a Russian physicist who was part of the team that found it. And they now think that the oldest ice in Antarctica could potentially be on top of this mountain, because ice flows away, as you'll see in a minute, from the point of origin. And what they've also discovered is that, in fact, Antarctica is the world's biggest wetland. There are all these underground rivers and lakes where you have liquid water underneath this huge ice cap. And the reason why the water is still liquid is partly because the ice cap acts as a blanket and holds in some of that natural thermal heat that comes from the centre of the Earth, and also the friction of the ice at the bottom of the interface between the rock and the ice is great to generate heat, and of course it's all trapped there. So consequently, we now understand Antarctica is also the world's biggest wetland, which is an amazing sort of contradiction. So 98% of it's covered by ice, but the 2% that isn't covered is very important. And you have these dry valleys where the geographic conditions, the winds, and that scour the valleys to keep the ice away. And then you also have small coastal areas where in fact there is vegetation there. Mostly it's mosses and lichens, but there's one or two plants there, angiosperms. And the problem is with global warming is that these vegetated areas are increasing. And then you also get sort of small offshore islands like this Deception Island, where it's actually an active volcano that's erupted quite a number of times, and so the heat from the volcanic activity makes it a place where a lot of tourist ships stop and people go swimming in a bay that is like a half a degree warmer than anywhere else. So it's not really a big deal, but it's a lot of fun. So one of the important things is that across Antarctica, the trans-Antarctic mountains split the continent, come all the way down the Antarctic Peninsula, and then the extension of them is the Andean Cordillera going all the way up South America. 2,000 kilometres long, and one of my other great adventures in my life was to join a team of people that sailed to Antarctica in the same tiny vessel I went to Mawson's Hut with to make it the first ascent of the highest mountain in a whole range of mountains called Mount Minto in North Victoria Land, the Admiralty Mountains. And we sailed there from Australia in the bicentennial year. You can see there it's 13,658 feet high, 4,000 metres, which is not very high by Himalayan standards, but you put that in Antarctica, which is so far south that it's actually equivalent to a mountain, maybe 10,000 feet higher in terms of the cold. And like I said, this mountain had been attempted by 4 or 5 different expeditions, and the big challenge was actually getting to it. The technical aspects of it weren't very challenging, but the logistics and the environment were extreme. So we sailed there in this tiny ship, and we had a 6-person climbing team and 4 people who ran the yacht, and they stayed there while we went off and sled inland. We had all sorts of adventures. It was probably the most amazing expedition I've ever been on. But we eventually got to the summit, and minus 40-degree wind chill, and managed to get back onto the ship safely. But getting back to Australia was a nightmare. We had contrary winds, and we were headed for Australia, but we ended up having to go to New Zealand. It took us about 2 months because we had force 11 gales. The ship was knocked down twice in storms where it rolls over and the mast is in the water. Pretty scary experience, but we managed to survive somehow. And I managed to contribute to another book in my authoring career. So 98% covered by ice, but how this ice flows is interesting. A flake of snow landing at the South Pole will take 100,000 years to travel all the way to the edge of the continent, and this ice starts to float when it gets to the ocean, and then as bits break off, they make giant icebergs. So where the ice shelves are is very interesting. You have major ones all the way around the continent. The Ross ice shelf here is the size of France, and so that just gives you an idea of the scale of it. And all that's floating, that's about 300 feet up in the air. Where the Ross ice shelf is, you have McMurdo Station, the largest of the US scientific bases, and it really is like a sort of giant mining town with large aircraft landing on the frozen sea ice early in the season and then up on an ice runway later on. And you can see how flat it is from space because of the fact that it's floating. And very early on, before the Antarctic Treaty came about, Americans took a small nuclear reactor there to try and power the place, but it didn't work very well, and they ended up having to remove it and then take many hundreds of tons, thousands of tons of soil that had been contaminated away. And so that was an interesting aspect of how challenging it is to be in these places, because you have to take ships in there, once or twice a year in the midsummer, and have icebreakers to carve their way up to Ross Island and offload many tons of diesel fuel that powers the station. In summer there may be 1,000 people here. In winter there might be 200. And so every spring planes fly with scientists, but technology is advancing so rapidly that now many scientists will go out into the field, put out remote instruments, and then come back and have data being sent back to them by satellite for years and years and years. So the need to be in the field all the time to do research is gradually becoming less and less as the technology gets better. So these ice shelves are very spectacular, and surface melting on a glacier or on an ice shelf can result in this incredible thing like a 300-foot waterfall coming off an ice shelf. And then you see these icebergs forming as they carve off and form, and big ones here, in fact small icebergs, and you have pack ice, which is part of the frozen sea left over. So a little bit of background about climate change and global warming. You have to understand these two terms. Global warming just refers to the rise in temperature on the Earth's surface, whereas climate change includes global warming, but refers to all of the things that are side effects, glaciers, melting, rainstorms, droughts, etc., which are part of the whole change in the system. And so when we talk about global warming, we mostly mean things that are the result of human activities like burning fossil fuels, whereas climate change can mean human-caused plus other natural factors. But it's incontrovertible that there has been, since the beginning of the Industrial Revolution, an incredible rise in the amount of CO2, 420 parts per million. We've actually reached about 408 in the last few weeks. And you can see the rise in average temperatures over that time. And so this is a very short time span, relatively speaking, only since the 1800s. But if you go back and use that ice core from Vostok, you can see there that in the last 400,000 years, the CO2 level has never risen above about, 300 parts per million. But only since 1950 have we had this enormous spike in the amount of CO2, which is this global warming gas that is really trapping the heat in the atmosphere. And these sorts of graphs also really show how dramatic that increase is in hottest average annual temperatures in the last decade, and how it's sort of starting to ramp up and go even faster. So one of the most important facts about this is all this heat that's coming into the atmosphere is warming the air only a little bit. We've only had a 1 degree centigrade, 1.5, 1.7 degree rise in temperature since the Industrial Revolution, but 93% of that heat and energy has gone into the oceans. And so the oceans are warming, and as oceans warm, the sea level rises because of thermal expansion. When something is heated like water, it expands, so that affects the sea level. And you also get the atmosphere heating up and melting glaciers, and so the sea level is rising because you have water that was on the ice caps around the world contributing to the rising sea level. And so it's really quite dramatic, the changes in the sea level, and that's having a huge impact on the future of coastal cities and a very big percentage of the population. And the greatest impact going forward is going to be on the rising sea level. Sure, the higher incidence of storms and the variability of weather is something to deal with, but the effect of sea level rise is going to be dramatic. And interestingly, the radar from satellites gives us all this information. NASA is one of the big success stories in the way they've been able to monitor the Earth's conditions, and so they have very good websites and great graphics showing how they are capturing this information, which is giving us so much important information about what's going on in the world. And there you can see the sea level rise, not very much relatively speaking, only a matter of 6 inches since the beginning, in the last 1,000 years, but the prediction is that it's going to be many, many feet. When you add carbon dioxide to water, you make weak carbonic acid, and so as the water heats up, it can absorb less carbon dioxide, which is a problem, but it becomes more acidic, which is very damaging to coral reefs and also to shellfish and a lot of life in the oceans that have limestone or calcium-based skeletons. So if we look at climate change in Antarctica, it's really impacting West Antarctica far more than East Antarctica. And in the past 50 years, we've seen an enormous increase in the loss of ice flying off the edge of the continent. And as it warms, you can see it's getting pinker and redder. And you know, this is what is it here? A low number to a high number. So as it goes down, it means that more and more ice is being lost more rapidly off the edge of the continent, especially here in West Antarctica, and we'll go into that a bit more in a minute. But you can see the flow lines all the way from the edge of the continent to the shore. And so over the whole of Antarctica, there is a tremendous amount of loss of ice from around the edges. But we know this because they have satellites there, a pair of satellites that actually measure the gravitational aspects of the Earth and can calculate the thickness of the ice very accurately by these two satellites. So if all of Antarctica was to melt, you know, there would be like 50, 60 metres of sea level rise, but that's not going to happen in a hurry. But the big problem is this sector here in West Antarctica. If that is very unstable and showing signs that it's in a runaway state, and we've already gone past a tipping point. You know, the ice caps and glaciers from around the world melting is significant. Greenland is very significant in the amount of contribution to sea level rise that it could make if it all melts, but it's West Antarctica that really has people worried. And we know all this information because it's collected and studied by the Scientific Committee for Antarctic Research, which is a separate organisation from the Antarctic Treaty, and it is very solid science that is being done there. And we now know that there are these 6 main points that are being affected by global warming in Antarctica. Antarctic hotspots, ice shelves breaking up, glaciers receding, there's more snowfall in Antarctica, more sea ice, and declining krill populations. So just drilling down a little bit into those things. The peninsula has warmed 10 times faster than the global average, and the increase in temperature on the peninsula alone has been 3 degrees in 50 years, which is, you know, the global temperature is 1 degree, Antarctica Peninsula is 3 degrees. And so you can see here the hot spots around the world are mostly the Arctic, Siberia, and here and Arctic, Svalbard, etc., and the Antarctic Peninsula. And so it's really a place that is an indicator of the degree of problem world over, but much magnified in those places. The ice shelves are breaking up because the ice shelves are floating, and if they melt, that doesn't affect sea level, but when they melt and break off, then the glaciers behind them flow faster, and so it drains more ice that was being supported by land, and that is what is going to affect sea level most dramatically.
We know that this ice shelf existed for at least 12,000 years. In 2002, 2/3 of it collapsed in less than 6 weeks. In the intervening period between 2002 and now, the remaining part of Larsen has also been weakening very, very quickly. We expect it will not last for more than a few years to come. This will undoubtedly affect sea level rise by putting more ice into the ocean. Now we have this rare opportunity of this ice shelf destabilizing and eventually collapsing in front of our eyes. And that will give us incredibly valuable lessons that we could use to understand what might be happening elsewhere in the future.
So pretty scary stuff. All of that is happening here in the Amundsen Sea, and 10% of Antarctica's glaciers are in retreat, and this is a particularly significant one as well.
We are heading towards a particular sector of West Antarctica draining into the Amundsen Sea. This sector is drained by 6 glaciers. The biggest ones are Pine Island Glacier and Thwaites Glacier. The speed of the glaciers measured by satellite is shown in color code. Red is fast, blue is slower, and green is the slowest. The glaciers flow into the sea and form floating extensions called ice shelves. Now in red are the areas where the flow speed is increasing almost every year. The darker the red, the more the glacier has been speeding up. You see that all the glaciers are speeding up. Now we focus our attention on the Smith Glacier, which is a smaller glacier, but which has experienced some of the most dramatic changes.
So these dramatic changes are mostly in West Antarctica, but in fact East Antarctica is cooling rather than warming, and that's because the hole in the ozone in Antarctica has resulted in a sort of bigger change in wind currents. This low pressure system here has meant that the wind speeds around and directions of the winds that circle Antarctica have sped up, and there's a northerly component to those winds, and that wind speed increase has actually kept a lot of the heat from the northern parts of the world out of Antarctica. So in fact, the parts of East Antarctica here are a little bit colder, and in fact snow is building up there, which is sort of contrary to some people's understanding of a warming situation, but it fits with the theories of global warming quite perfectly. And that also has impacted on sea ice in Antarctica. You remember, the minimum in February and the maximum in September. There's a lot of variability here, but in fact, the ice around Antarctica has been increasing by about 1% per decade. And the hole in the ozone is now shrinking again. It sort of grew quite rapidly, and then when we banned chlorofluorocarbons, it started to retract. But the hole in the ozone has actually been sheltering Antarctica from the worst effects of global warming, ironically. And so you can see here that the increase in sea ice is significant, but it nowhere near matches the mass and the degree of land ice that's being lost from the glaciers all around the continent. And that has a big impact on the biology of Antarctica. The sea ice is being lost dramatically around the edge of the West Antarctic Peninsula, and it's seen a krill decline of 80% in 30 years, and the penguin populations are also affected. Adelies are like the indicator species. It's very hard to measure krill, but if you look at the success of the adelies and their breeding, and you can understand more about what's happening to the krill, and that's related to sea ice. And on the peninsula, the adelies are declining, and the gentoos are taking advantage of it because they're able to change their diet, and also they're more flexible in their breeding behaviours. And warmer temperatures on the peninsula mean more moisture in the air, which means more snowfall, which makes it harder for adelies to nest because they can only lay their eggs when it's free of snow, when they can have a rocky nest, and so the adelies are being pushed out of Antarctica. And overall, around the world, penguins are suffering. Of the 18 species, 10 are threatened and 2 are endangered. So there's a big myth about penguins that they can't fly, and I'm here to dispel that myth.
This recently discovered colony of penguins is unlike any other. They don't need to huddle together every winter for protection against bitter cold, because these little fellas can do something no other penguins can. Isn't that amazing? How do they use this incredible ability? Well, they fly thousands of miles, rainforest of South America, to spend the winter basking in the tropical sun.
So you have to realise that the BBC produced this on April the 1st, some years ago, but it's a very nice sort of pointer to the fact that penguins can't escape the cold and the changes in Antarctica like some other creatures can that can migrate. Penguins are stuck there. So, in terms of dealing with Antarctica, we either have to adapt to the fact that the world is changing or try and slow down the changes. Those are two different approaches, And as a nation, America is sort of lagging now in its attempts to mitigate, avoid the build-up of CO2, and we're not doing a very good job of adapting either. But the rest of the world is marching forward and making huge strides in addressing climate change, but America needs to come around very quickly, and that's my hope. So, there are these telltale signs of adaptation in the animal world, and I want to finish on a little bit more positive note, showing you just some of the highlights of our very brief time going to South Georgia. On our way home from that voyage I started earlier in the talk, and going to this amazing place, which is in fact not part of the Antarctic Treaty Area. It's a British protectorate, an overseas colony, and they maintain a fishing rights to that area, and so they have their own income. It's a tiny spot, but it holds some of the most amazing wildlife that you can experience in the world. That has the king penguin, which stands about 1 metre high, and these are a subantarctic species that are probably the most beautiful bird of all. The chicks are so differently feathered in their early stages that they look like a completely different species. And then you have these huge elephant seals that were plundered almost to extinction for their oil, and they've recovered significantly, as have the fur seals. But they sort of, this is their territory, and when we visit there very briefly, they move in and sort of take over, as is their wont. And so we visit a number of places in South Georgia, and the most interesting one from a historical point of view is the station which used to be the main whaling station in Antarctica, and Shackleton, the famous English explorer, is in fact buried there. And so you sail into this abandoned whaling station, and they have a fantastic museum there, a whaling history museum, and they've restored one of the old whalers' churches that was taken down and erected in Antarctica. This is the ship that Shackleton, or a replica of the small lifeboat that Shackleton's team used to travel 600 miles to effect their own rescue. An old whale chaser that was abandoned. And so from 1904 to 1930, this was a thriving industry with a dozen or so of these whaling stations all around South Georgia, plundering the great whales for their oil. And so we always pay homage to Shackleton and one of his key men, Frank Wild, with a little tipple of whiskey on the grave. And then we move on to Salisbury Plain, which is probably the most spectacular of all places in Antarctica, or the Antarctic region, and South Georgia is the sub-Antarctic, of course, but here you have 60,000 king penguins nesting in there year-round. So being able to visit this spot, even in crappy weather, is just a life-changing experience. We finish up with just a quick visit to an wandering albatross colony on Prine Island, where we see these magnificent wandering albatross that have a wingspan of maybe 16 feet, and see them doing their mating dances and then taking off and flying. It's a very protected area. There's the only boardwalk in the region. To get to the spot, you can only visit a very few months of the year, and so that's a real great final highlight of a trip to Antarctica and the South Georgia region, is to see the albatross and this very unique blonde fur seal. So we end our trip back at Port Stanley, and there's an argument that tourists shouldn't go to Antarctica, that we're imposing our Western ways and burning all that diesel fuel going down there. But one of the countering arguments is the fact that by experiencing this place, we're contributing to scientific research, and we're also able to educate people about the importance of Antarctica by a few of us being able to go there. And of course, some of you who, if you have a passion, can somehow work out a way to get there. It can be a trip of a lifetime. So I'd like to thank all these people who helped make my presentation here this afternoon or this evening possible, and especially thank Cormac for inviting me. Thanks very much.
Likes to talk a lot. If you want to ask a few questions, I'm sure you'll be happy to answer them. Otherwise, you're free to go.
Thank you.
Thank you.
Great.
Okay. Well, you know, catch me later. I'm going to be around all weekend if you really want to go there and want to know how or have something that is a burning question. Thanks very much for your interest and attention.